Hi, my name is Chris Cutler. I'm at the Nova Scotia Agricultural College in Truro, Nova Scotia, Canada, and I spoke today on insecticides, insects, and agriculture. It's a topic that's a little different than what we've seen at the conference so far, but I wanted to emphasize a couple main points. First off, insects are extremely important. They're very abundant, very prominent in agriculture, and in those same systems, there's a lot of chemicals to which they're exposed. And it's been suggested that, along with other factors, hormesis could potentially be a factor causing, at least in part, population surges in those pests that sometimes occur. And this is a major issue because if you get those population surges, of course, then a farmer would come in with more product and apply more pesticide and exacerbate problems like environmental contamination, resistance, and those types of things. It's also an issue with resistance because doses that are typically used in the field to target an insect pest would, for a resistant population, actually be quite low. So they would be in that hormetic NOAC zone, and that could induce stimulation of those resistant populations in the field. There are a couple issues, I think, that need to be resolved. One is dealing with the magnitude of the response. In some cases, fecundity, for instance, in insects tends to be well above that 30 to 60% above the control level. Sometimes it's triple or more that. And also the dose range. Sometimes we see stimulation quite significant at doses well above the NOAC, so doses approaching the LC25, for instance, or even higher in some cases. And we're getting a lot of tools now in molecular biology, of course, and because insects are so easy to rear in the lab and we get such great numbers, we can control their genetics as well. I think there's a lot of opportunity to understand better the mechanisms of the mechanisms of hormesis using insects as models.